Today we're integrating tangent sine inverse t over square root 1 minus t squared with the upper limit of 1/2 and the lower limit of 0. So the first thing you need to notice is sine inverse is actually an angle. Let's go ahead and create the triangle right now. Theta. So we got opposite, adjacent, and hypotenuse. So let's go ahead and put the sine inverse 1 t is equal to theta. We want to isolate t, so we're going to put sine on both sides. So let's make some room for this. Sine theta. So sine and sine inverse would cancel. So t is equal to sine theta. Let's go ahead and put it over 1 for SOHCAHTOA. So we do need to know SOHCAHTOA, which is SOHCAHTOA. So we know sine theta is equal to opposite over hypotenuse. So we know what the opposite is, which is t, and we also know what's the hypotenuse, which is 1. So let's go ahead and label a triangle. So opposite is equal to t, and hypotenuse is equal to 1. Now we need to find out what adjacent is. So adjacent is equal to a squared, adjacent squared, plus t squared is equal to 1 with the Pythagorean theorem. So let's go ahead and minus t squared on both sides. And also we also need to square root. Let's go ahead and square root both sides. We end up with a is equal to square root 1 minus t squared. So that's what adjacent is. Let's go ahead and label that. We also know what tangent is. So tangent is opposite over adjacent, which we do know, which is t over square root 1 minus t squared, which is right here and here. Let's go ahead and input it into our original problem right here. Let's go ahead and move it down here so we can have a good view of it. So we're going to input this in. Oh, you know what? Let's go ahead and rationalize it. Let's go. So t over square root 1 minus t squared. So we're going to go ahead and rationalize it. As you can see, when the numerator and denominator is together with the same value, it's always equal to 1. So we're just multiplying this by 1, which is itself. So it's the same value. You got t square root 1 minus t squared. This is actually equivalent to 1 minus t squared 1/2 times 1 minus t squared 1/2. When there's two exponents with the same base, you actually add it, which is 1. So this is 1 minus t squared. And let's go ahead and input this to the original problem. So we got t square root 1 minus t squared over 1 minus t squared over square root 1 minus t squared. So we're going to do the same thing. We're going to multiply the numerator and denominator with the same value, which is equal to 1. So it equals to the same value. So we got 1 over square root 1 minus t squared. So we do it on the numerator and the denominator. So these will actually cancel out. So we end up with, so we still have the same limits. So we got t over 1 minus t squared dt. So we're going to do a u substitution, which is u is equal to 1 minus t squared. We're going to go ahead and substitute the denominator by u. So we're going to derive both sides, which is negative 2t dt. So we're going to isolate the dt for the substitution. substitute this value to t. T will cancel out, so we got negative 1/2. We could move that into the front because it can be moved into the front of the integration. So 1/2 0 over u du. So the integration of 1 over u is ln u. So we're gonna go ahead and do that. So we got ln u negative 1/2. Now we're gonna input the u value again. So we have negative 1/2 ln 1 minus t squared. And let's go ahead and put the limits now. 1/2 and 0. Move this up. Now all we need to do is do the limits. So we got negative 1/2 ln. Let's go ahead and put 1 minus 1/2 squared minus, let's put the brackets for this so it won't be confusing, ln 1 minus 0. Go ahead and finish in the brackets. So ln, this is equal to ln 1, which is 0, so this goes away. So we end up with 1 over 4 minus 1 ln absolute value 1/2. So we know that 4 over 4 minus 1 over 4 is basic fractions. So we got 1/2 in the front. And let's go ahead and compute the fractions. So we got 3 over 4 1/2. So we could move this to the exponent, and this will actually flip the value. So we have 1/2 ln 4 over 3, and that is it.